Hey everyone, my name is Mahi Chowdhury. I'm a PM here at Microsoft for App Control, and I'm joined with my colleagues Jordan and Carlos. And today we will be talking about App Control for Business for today's Microsoft Technical Takeoff. So today we're going to do a quick refresher on what the security ad is for Microsoft's App Control for Business. We'll go over what's new, and we'll deep dive these into 3 different topics. One is script enforcement. Second is Azure Arc, and third is session locked policies. We'll end the session with some new additions to our Wizard app control tool, as well as documentation. App Control for Business is Microsoft's default deny application security for enterprise customers. It's built-in directly into the Windows kernel across both client and server platforms. Being kernel integrated also means that App Control can validate everything that executes on the system, from applications, scripts, installers, and kernel mode drivers, not just user mode processes. Additionally, because enforcement happens at this kernel level, there's no need to deploy or maintain any third-party agents, which reduce your overhead and strengthen security all around. App Control is designed to be deployed and operated as a continuous lifecycle, not just a one-time allow list exercise. Organizations can start by defining policies, observe, audit, real-world execution, then refine based off what's actually running, and finally deploy widely with confidence. This lifecycle is powered by deep integration with broader Microsoft security ecosystem. Microsoft Defender, specifically MDE Advanced Hunting, provides audit and block telemetry to help organizations understand what's running, what's being blocked, and why. That visibility allows you data-driven policy refinement. Our recommendation is to use Sign and Reputable Template Policy, which uses the ISG, Intelligent Security Graph, to apply cloud-based reputation signals for anything that is not explicitly trusted. Now, for deployment and management, App Control integrates with Microsoft Intune for client endpoints and Azure Arc for servers. App Control is supported for Windows 10, Windows 11, and Windows Server. No hardware nor licensing requirements are needed, making this super easy to use. In today's presentation, we'll be sharing new improvements, including script enforcement, Azure Arc support, session-locked policies, our inbox CI tool, the Wizard, as well as new improvements to rebootless operations, and lastly, overall guidance within our public-facing documentation. And now I'll hand over to my colleague Jordan to talk about script enforcement.
Thanks so much, Mahi. Hi, I'm Jordan Girton. I'm a senior PM here at Microsoft and Windows Security. Today I'll be touching on script enforcement and the new experiences we have in application control. One of the biggest changes we're excited to announce is the improved script enforcement experience in App Control. App Control has had enlightened script host support for years, PowerShell 5 and some other inbox script hosts, but the experience has been disconnected and frustrating for our partners, with some disabling script enforcement altogether. As of Windows 11 24H2 and Server 2025, we have 2 new script hosts integrating with App Control. This new experience is also supported on Windows 11 25H2 and 26H1 as well. PowerShell, also called PWSH, is now completely integrated with App Control. Scripts that do not pass policy are now fully blocked from executing in PowerShell, as opposed to being run in constrained language mode like the behavior in PowerShell 5. Similarly, command prompt is now fully integrated with App Control. Like PowerShell, scripts that do not pass policy are blocked from running in command prompt. Let's take a look at how this works in practice. To get started with the new script enforcement behavior, we recommend starting with the App Control Wizard, which is available for download at ak.ms/wizard. Once downloaded and installed, the wizard can be used to create or modify an existing policy to enable script enforcement. Here, I'm going to edit an existing policy to add trust for my line of business script signing certificate. In the policy rules section, we want to first ensure that disable script enforcement is not checked, so App Control evaluates scripts. We also want audit mode off, so I'm getting the enforced protection of scripts by App Control. In the files rules section, we want to select Add Custom Rule to add an allow signer rule for our signing certificate used to sign our scripts. We're going to set the rule type to certificate file. We're going to use the wizard to browse for the certificate file on disk. Once the wizard creates the XML file, we're going to open the file in your favorite text editor and add the following app settings objects to your XML policy. Each app setting object has a path to the app manifest file, which is a file describing the setting schema and properties to app control. The app manifest file can be local or remote. For PowerShell and command prompt, we'll see that the manifests are available on our Microsoft Docs Git repository. Each setting also has the setting name and its Boolean value. The setting for command prompt is called Enable App Control, while the setting for PowerShell is Block Script on Policy Failure. Both settings are opt-in. After converting the policy XML to SIP format, the inbox utility CI tool can be used to activate the new policy using the -up command. Now we can test the new behavior of our scripts. In PowerShell, when I try to run a script that is not allow listed in my app control policy, you'll see PowerShell throws an error and will block the script from running in my environments. This protects my users and assets from untrusted scripts. Alternatively, when I run a script that is signed by the certificate I added into my policy using the wizard, PowerShell allows my trusted scripts to run, which writes the PowerShell version to console and outputs I'm a trusted script. Similarly, in command prompt, when I try to run a script that does not pass my app control policy, command prompt will check with app control and block the script from running in my environment. An error message is again thrown to the user. Conversely, when I run a script that is trusted by the policy we built in the wizard, command prompt determines that the script passes app control and allows the script to execute. App Control now supports a new framework to easily integrate with the product. We have created an extensible model where you can tailor per application settings based on the states of those settings across your policies that can be integrated into your line of business applications. This is the same framework that is powering the new behavior we just saw in PowerShell and command prompt. To integrate with App Control, we just need three things. First, an App Control manifest file that can be on your system or remote, for instance, on GitHub. This file will describe the app setting to App Control. Second, the app setting definition. We need its name and its type. App Control supports both Boolean and strings for the settings. Third, calling the new Windows Lockdown Policy or WLDP API within the application. There is one API for each setting type. With these three pieces in place, your organization or users can write App Control policies which use and set the state of these new settings. You can also build applications that use these new settings and integrate with App Control for business as well. Let's take a look at how App Control handles policy evaluation. The behavior of the setting evaluation logic depends on the setting type. Within a policy group, which is composed of one base policy and its supplemental policies, only one policy must set the Boolean setting. Across various policy groups, each group must have at least one policy enable the setting. For string sets, the behavior is a little different. App Control returns the strings set by taking a union between the base and its supplementals, and the intersection across all groups are returned by the API. Lastly, strings are concatenated across policy groups and within policy groups. Let's take a look at an example of an application I integrated with App Control. Getting started requires an app manifest file describing the application's new setting to be defined in the policy. The manifest file, like I mentioned before, can be stored remotely, in which case App Control will parse it from the network, or locally. Each manifest file must have the application ID and one or more settings definitions. Each setting definition must have the name, its type, and whether you want App Control to ignore the setting within audit mode policies. In the source code for the Enlightened application integrating with App Control, we must set the application ID, which matches the ID in the app manifest, the name of the setting, as well as the WLDP API call. For my Boolean setting, I'm using the WLDP get app setting Boolean API. If app control determines that all policies have the allow connection setting and the setting is set to true, my application will allow the managed user to securely authenticate and connect to confidential data accessed by this application. Otherwise, the application fails to authenticate and access to the data is denied. The last step is declaring the new app setting in your app control policy. The app setting requires, again, the path to the app manifest file, the name of the new setting, and the value or state of that setting. In this case, I have set the allow auth connection setting to true. Let's take a look at the new behavior of the enlightened app once the app control policy has been deployed. The managed user begins logging into the secure sign-in app to access their confidential data. The sign-in button click action calls the new API where app control goes to work, checking and reconciling the state of all new app settings across the policies. Auth is successful, so app control determine all policies support and enable the new setting. Alternatively, if we deploy a new policy that does not allow auth connection for this user, or the original policy allowing the setting is removed, we see that upon user re-authenticating, app control determines that not all active policies enable our new setting, and the user receives an access denied error bubbled up from the new WLDP APIs. In practice, these new app settings and APIs can supplement app control on systems and improve application security by integrating with app control. Thank you. With that, I'll hand it off to Carlos.
Thank you, Jordan. My name is Carlos Mayol. I'm a technical program manager in the Azure Edge security team. And today I'm going to walk you through the Azure Arc experience that we combine in the latest releases of Windows Server. Particularly, I want to talk to you about this life cycle of using app control for business in a journey from deployment to any day after you deploy to production. As you can see on the screen, after you deploy your systems, app control is already enabled by default. And it will start always protecting you for any malicious, what we call kernel driver. After that, it's up to you to decide how you want to handle the insights that the product capability offers you. The integration with Azure Arc will give you the ability to get insights at a scale to your deployments, and that's why I want to talk to you. So in order to do that, there is two basic steps to do. Number one, as you know, you want to deploy at least one policy for app control to start understanding the code integrity posture of your systems. After you do that, ideally, you will have your Arc-enabled systems reporting to Azure Monitor. Then is when you can use or crafted Azure Workbook to understand that insight that is going to be flow from your devices to Azure. After that, you can ingest that data into the app control wizard to create your supplemental policies. That's basically the whole process from deployment, consumption, and distribution of your supplemental policies that will cover any Microsoft policies and any additional policies that you might want to create. So as many customers are already telling us, one of the first steps that I mentioned previously is to deploy the first base policy. This is basically your standpoint, how you want your systems to be protected against malicious code and to have a very good initial starting point. One of the goals that we had in our team was to provide a very easy experience for you to create this base policy. So what we did is we leveraged the ability of a framework that we have in the OS on the Windows Server ecosystem called OSConfig. Today, I'm not going to talk to you more about OSConfig, but just think about it as a configuration framework layer. And we did it super easy. There is basically two commands. One, to install the OSConfig module, which is a PowerShell engine that will allow you to download and install the payload. In this case, the payload is an app control policy that you can either add in audit mode or in block mode for you to start leveraging from day one, everything in just one simple step. So the idea after that is that you're going to start all the data flowing through the app control layer to your Azure Log Analytics. That's where you can go and install in your Azure Monitor workbook to start seeing how your systems behaves. It is easy to see the behavior when you have 1, 2, or 10 systems, but imagine that you are trying to monitor hundreds of systems in one single class of plane. If you want to see it in a consolidated dashboard. With that said, you can just go to aka.ms/app control workbook, and you will find an easy instructions for you to follow. That's it. That's all you need to do. After that, you can monitor your fleet, and when the time comes, you can just select all the information to be exported into the App Control Wizard. So let me go through the App Control Wizard integration with Azure Monitor. Just a few chapters to tell you how it is. Ideally, what you want to do is to first deploy the Microsoft provided policies, as I mentioned to you. I really recommend you to go first in audit mode, because I assume that you're going to have additional third-party ISV application that you want to install and use in your systems. After you follow all that process of all your applications, then we're going to start creating all those insights in the local event log. Those event logs will fly through the Arc agent to the Azure Monitor, and then we're going to start capturing all that data. At the end, as I mentioned to you, on the workbook, you're going to be able to see audit events or block events in case that you already had the block policies in place. And it's just the time for you to start creating your supplemental policies. So basically, those 3 easy steps will allow you to start deploying App Control at speed on your production systems. So this is how basically looks the App Control workbook, where you can see all that data flowing. Then you can see and search all the information that you want from all those insights. And when the time comes, as I mentioned to you, you go and explore a selected amount of events and ingest it in the App Control Wizard. You will create your supplemental policies, and the repeat goes on. Every time that you want to add additional software to your fleet, you would follow the same process, and that's it. And with all that, I'm going to take over to Mahi.
Thanks, Carlos. Now we'll have our third deep dive, which is session locked policies. In this section, we're going to talk about app control policies, how they are enforced, why session lock policies are an important option for customers moving beyond just the regular basic policy. When customers adopt app control, one of the most common questions we hear is, how durable is enforcement, and what happens if someone tries to remove or bypass a policy? This table shows 3 enforcement models ordered from most flexible to most protected. On the left, we have regular policies. These are enforced using standard OS controls and can be added or removed without a reboot. This makes them great for a starting point for organizations new to app control, but still least resistance if someone unintentionally or intentionally removes the policy. In the middle is the session locked policies, which is the focus of this slide. Session locked policies are enforced at the user level. Once the policy is applied, it cannot be removed while the session is active, even by the admin. If an app or script is blocked, it remains blocked for the entirety of the session. And the policy can only be cleared by ending the session with a reboot. This gives the customer a strong, predictable enforcement model without some of the operational overhead of the UEFI locking, which is on the right. We have these UEFI locked policies. These are enforced at boot time and before the OS fully starts. Because the policy is stored in firmware and protected by Windows boot process, it can't actually be removed without a signed policy update as well as a reboot. This ensures the highest level of tamper resistance. UEFI locked policies are usually best suited for servers or critical infrastructures where security durability is top of mind. Now, it's key to take away that these options are complementary, not mutually exclusive. So many customers start with regular policies, and as they mature, move to these session locked or UEFI locked policies which are for their highest risk or most critical systems. Next, we'll shift over to a demo. I'm going to show how to create a session locked policy, deploy it, and demonstrate how the enforcement persists for the whole duration of the session, even if the policy is removed. I'm starting to create a policy using the WDAC wizard, specifically that policy creator setting. I'm going to use the default multi-policy format. Next, I select the signed and reputable base template. First, I remove the allow supplemental policy and turn off audit mode. This ensures we're starting with a clean, enforced baseline. Next, I'm going to add a custom deny rule using a path-based rule, and I explicitly target here Google Chrome. This could as easily be a script or a line of business app. Chrome here is just an easy visual example. With the rule in place, I'm going to now generate a policy. At this point, we have a standard enforced WDAC policy. Now, to make this session policy session locked, in the policy XML, I'll add this setting, which is a single setting change that changes the enforcement model. It tells Windows this policy is active, it cannot be removed for the duration of the session. Because the session lock policies must be signed, we now update signing information. Next, in PowerShell as an administrator, I'm going to convert the XML into a binary format that Windows enforces. Next, I'm going to deploy the policy using CI tool update policy. At this point, the policy is active and enforced. So I'm going to try loading up Chrome, and it should block. Here's when the session locking becomes more visible. I'm going to next attempt to remove the policy using CI tool. Even though the policy is still removed, Chrome is still blocked. Finally, I'm going to reboot the system, and after the reboot and the session ends, the lock should be released. With the new session, as you can see, if I reattempt to load Chrome, it is no longer blocked. In this next session, we're going to talk about some new improvements to both our wizard and documentation additions. As you can see, we've referenced the wizard tool multiple times during today's session, and some even new additions include things like event log parsing for MDE advanced hunting logs, log analytic events, and Windows event logs. We also have new rule type supported, user and kernel mode recommended blocks, and app ID tagging policy support. For our documentation, we have now adjusted our docs to be as prescriptive as possible to get customers started without the knowledge of knowing what apps you may run. The goal here is to construct a policy that is going to have the fewest blocks and still deliver the security protections desired. And on behalf of Jordan, Carlos, and myself, we thank you for listening in on App Control for Business New Improvements. Thank you so much.